Okay, so today we're going to be talking about segment addition and writing equations for lines. Today during class you should have drew your pictures using lines and line segments and even circles. Tonight we're not going to talk about circles, but just the line part. By the end of this you should be able to name and write equations for lines and line segments. Easy enough. So let's start off by naming line segments. Okay, so a line segment is a segment of a line. That's easy enough. So if we have our grid here, and we have a line segment that goes from this point to this point. There. Line segments are named by letters and not points. So this will be named A, B for now. To write that, all you do is write A, B, and put a line segment above it. That would be the name of this line segment, A, B. Easy enough. But now I want to know the length. So let's talk about finding the length of line segments. Length of line segments. So what is the length of AB is what we're trying to figure out. AB is a diagonal line, but I'm going to turn it into a triangle to find the length. So let's do this. Let's do this. It must be a right triangle because you're going to use Pythagorean theorem to find what this length is. So let's count up. 1, 2, 3. So that length of the triangle is 3. This length is 1, 2, 3, 4. So I need to figure out what this length is. Pythagorean theorem says that a squared plus b squared equals c squared, where a and b are legs and c is the hypotenuse. And you may not be able to see all that. Oh yeah, you can. Okay. So what are my legs? Well, they're the part that are straight lines and not diagonal. So they're 3 and 4. So let's plug in. 3 squared plus 4 squared equals c squared. 3 squared is 9 plus 4 squared is 16 equals c squared. So c squared equals 25. Now, am I done? No. I've got to figure out what c is, not c squared. So I've got to do what? What's the opposite of squaring something? Square rooting it. So I square root both sides, because I can't just do one, I have to do both sides. I'm going to get 5. The square root of 25 is 5 equals c. C was my what? My hypotenuse, which was the diagonal, which is what I need. That's what AB will be. Well, that's what the length of AB will be, which is 5. So the length of AB equals 5. Beautiful. Okay? So now we have the length of line segments. We've named line segments. Let's talk about lines. Actually, no, let's do addition first. Sorry, I'm all over the place. I know. Let's say that we have another point over here. And for the sake of argument, we'll name it C. So now I have line segment AB, and I must also have line segment BC. I want to know what the length of BC is. So if I'm finding BC, I'm going to do the exact same thing I just did. I'm going to turn it into a triangle. I can turn it into a triangle this way or this way, it doesn't matter. Let's do it on the outside so you don't get confused. It's a right triangle, so I'm happy. How far did I go up? 1. How far did I go over? 1, 2, 3, 4. Now I need to find out what the hypotenuse is, which is the diagonal. So here's a leg, here's a leg. Let's plug in. 1 squared plus 4 squared equals c squared. 1 squared is 1, 4 squared is 16. So I add those together, I get 17 equals c squared. Am I done? Nope. I gotta figure out what the c is, not c squared. So to do that, I do the square root of both sides. C equals the square root of 17. 17 is prime, so I am done. I do not want a decimal. I want in the radical form. So leave it as square root of 17. So BC equals the square root of 17. Now, what's the equation? The question was, what is the length of AC? AC. So that is from here to here. But do I do a straight line? No, because there is no line segment there. I can only go where there are line segments. So I go from A to B to C. So the length from AB was 5. Let's do this. The length of AB plus what will get me to C? Well, the length of BC will get me to C. Equals the length of AC. Now I can just plug in. What's the length of AB? We said it was 5. What is the length of BC? The square root of 17. Can I simplify these? 5 and 7 square root of 17. Can I butt them up against each other? No, because they're not being multiplied. So that's your answer. 5 plus the square root of 17. Can you see that? Yes, you can. Okay. Moving on. That's segment addition. Now we're going to get into lines. Not line segments, but lines. So if I have my coordinate plane, and I have a line that goes through this point, and we'll do this point. Okay, it goes through there, and it goes on forever. So naming lines is just like line segments. Naming lines. If this is C and G, and they're on the line, then the name of the line is CG. What was the difference that I just did between a line segment and a line? I added me some arrows. Okay? That's what shows it's a line. So that's easy enough. Pick 2 points that are on the line. If I have a point here, that's D, and this point over here is B. The name of this line could be CD, it could be CB, it could be GB. Doesn't matter. As long as there's 2 points on there that have names, you can name the line. Now, I want to know the equation for this line. We'll leave GB on there. So we'll put, and I say, what is the equation for line GB? Well, I know it's a line, because it's got the line notation, and I know what the equation for the line is. I told you last night. It is y equals mx plus b. Y and x will stay the same. M is my slope, and b is my y-intercept. So I don't have to worry about y or x, but I need to find slope and y-intercept. So let's figure out this slope first. Slope, which is m, which equals slope, which also equals, what is slope? Slope is rise over run, which is also, and yeah, I'm still going, how far you go up or down over how far you go to the right. So we're going to start to the left and go to the right. So if I start at G and I go do my rise first, I go up or down, I'm going to go down 1, 2, 3. So I went down 3. Because I went down, it's negative. Now I go to the right. We're going to pretend that I went through that mark right there. And I went 1, 2, 3, 4. Down 3 over 4. That, my friends, is your slope. So now I can plug it in. Y equals negative 3/4 plus my y-intercept. What is my y-intercept? Where does this line touch the y-axis? Perfect. 1. Touches at 1. So that's my y-intercept. And that, oh, I forgot my x. That is the equation for your line. Very, very good. Okay? That is your code word for tomorrow. So, we've done our naming lines and our line segments and doing all that good stuff. Can I pause this? I cannot. So what we're going to talk about now is what we're going to do for in class tomorrow. So let's say today during class I gave you a grid and you made a beautiful picture of your house. And you said that your house looks like this. You started here, went to there. I have another email. And then it has a garage, so you went over here and you went, I guess I need to do this in green. You went over, you went up, and you put a roof on it. Okay, and then you come over here. You put another roof. Then you went right here and you put yourself a garage door. And you put a normal door. So there's your beautiful little picture made out of lines. Your line should have went to every single, to points, exactly on points. Not just floating out randomly somewhere. So what you're going to do tomorrow in class is you're going to name all of these. A, B, C, D, and E. Keep going. Let's name that F, G, H, I, J, K, L, M, N, O, P, and lastly, Q. So you've got the alphabet all over your picture. What you're going to do tomorrow is you're going to list, and I know you're going to hate me for this, the lengths and the names of all of your segments and lines. Now, do you have any lines? You might. For instance, this one could be a line. Your horizon, it goes on forever. So the name of that line would just be line A, and pick any of those letters on the line. Let's do C. And its equation is y equals, what is my slope? Well, it doesn't rise, so it goes up 0, and it goes over 1. Well, what's 0 over 1? 0. X. And what does it intercept the y-axis? 1, 2, negative 2. Now, do I have to put this 0x? Because no, it's being multiplied by 0. So my solution is just y equals negative 2. There's an example of your line. Tells me an equation and the name's the line. You're going to do that for all your segments as well. If you have your picture at home and you have nothing to do tonight, you're more than welcome to start working on this. But yeah, don't forget your code word, and we'll see you tomorrow.